Free fall. A free-falling object is an object that is falling under the influence of gravity.
That is to say, that any object that is moving and being acted upon only by the force of gravity is said to be in a free fall. Such an object will experience a downward acceleration of 9.8 meters per second squared. Whether the object is falling downward or rising upward towards its peak, if it is under the sole influence of gravity, then its acceleration value is 9.8 meters per second squared. Here are some concepts to apply to problem solving. First, if an object in a free fall experiences an acceleration of negative 9.8 meters per second squared, then the value of acceleration in the kinematic equations is negative 9.8 meters per second squared for any free-falling object. Second, if an object is merely dropped from an elevated height, then the initial velocity of the object is 0 meters per second. Third, if an object is projected upwards in a vertical direction, then it will slow down as it rises upward. The instant at which it reaches the peak of its trajectory, its velocity is 0 meters per second. Fourth, if an object is projected upwards in a vertical direction, then the velocity at which it is projected is equal in magnitude and opposite in sign to the velocity that it has when it returns to the same height. There are four known kinematic equations. The first one is d equal to vi times t plus 1/2 at squared. Next is vf equal to vi plus a times t. The third one is vf squared equal to vi squared plus 2 times a times d. And the last one is d equal to vf plus vi over 2 plus t. The letters in the formula have a specific meaning. The symbol d stands for displacement, the symbol t for time, a for acceleration, vi stands for initial velocity, and the symbol vf stands for final velocity. These four principles and the four kinematic equations can be combined to solve problems involving the motion of free-falling objects. A bottle of water was dropped from a third floor of a building. A bottle of water is dropped from a 115-meter tall building. What will be the velocity when it reaches the ground? First, we try to find the value or the data given and try to write them down. So first, we have our d, or our displacement, which is 115 meters. Next, we have our initial velocity, which is 0. Then, our acceleration, which is negative 9.8 meters per second squared. And our unknown, which is the final velocity. So now that we know the given values, which formula do we choose? Remember that I gave you four kinematic equations. It could be a little tricky, but the only way to find out what to use is by looking back to your data that was gathered. So we have initial and final velocity, acceleration, and displacement. We don't have time, since it was not mentioned in the problem. Now let's go back to the formulas and check for some similarities. So we need to find a formula that doesn't have time. Since the first, second, and fourth formulas have time, we need to use the third one. So final velocity squared equal to initial velocity squared plus 2 times acceleration times distance, or displacement. Now we input the values that were given. First, initial velocity is 0, so it can be cancelled out. Then we have 2ad. Acceleration is negative 9.8 meters per second squared, and displacement is 115 meters. So we multiply the three terms. 2 times negative 9.8 meters per second squared times 115 is equal to negative 2,254. Then after, we need to find a square root to cancel out the squared of final velocity. And then the final velocity would be negative 47.48 meters per second. An object is dropped from the top of a building. The time was calculated to hit the bottom was 4.27 seconds. What is the height of the building? So again, we need to write down the given values. So first we have time, which is 4.27 seconds, our initial velocity of 0 meters per second, and our acceleration of negative 9.8 meters per second squared. And of course, our unknown, which is the displacement. The formula that we're going to use here is d equal to initial velocity times time plus 1/2 acceleration times time squared. So initial velocity is 0 times time of 4.27 seconds is equal to 0, so we can cancel them out. Plus 1/2 of negative 9.8 meters per second squared times 4.27 seconds squared. Then the answer would be negative 89.34 meters. However, there is no negative displacement, so the final answer would be 89.34 meters.